Let's now operate rational numbers. Let's start with the sets of integers. This is the pre-break session for the topic on operations of integers. Let us try to solve or determine the results when these integers are simplified under the given operations. And then secondly, I have designed here a real-life problem that may use the concept for solving in or simplifying the operations on integers. Let's try to have number one. In number one, we have here 13 plus negative 6. If we talk about operating integers, specifically for addition and subtraction, it is always easier for us to look at how terms or integers are added together. Here we have 13, and then we have plus negative 6. There are many rules to answer this problem. You could actually use the rules on signs or even the concept of moving towards the left and the right. Well, moving towards the right is positive and moving towards the left is negative. Or you can also use my technique that I have used when I was at your age as well. I'm talking about borrowed money, and then you have there your payment or the debit and then the credit. If we talk about here, 13, I have here 13 pesos. Okay? When I have 13 pesos, I will add here this amount here. But if the integer is a negative number, I will still think of it as a borrowed money. Okay, or in vernacular we to call it utang. Okay, so if I have here 13 pesos and then I have here, because the plus could also be considered as and I have here 6 pesos, which is borrowed money, assuming that I will pay the same amount of borrowed money, I only have 7 pesos left. And this 7 pesos is a actual money, not anymore borrowed or hindi, not anymore utang. So I have here 13 pesos and I have an utang which is 6 pesos. If I'm going to assume that I'm going to pay it, I still have 7 here, and the 7 is the remaining amount which is in pesos, not borrowed money. Okay? So this is how it goes. Okay. Considering the different techniques, you can also use yours, but I am using this technique because it's easier for me. Number two, if I have here negative 7 minus 21 minus negative 2. Now, then again, there are many rules in subtracting integers because these are all under subtracting integers. You have negative 7 to be subtracted by 21 and again subtracted by a negative 2. When you have multiple of negative or even subtraction symbols, it will actually somehow confuse you. So my suggestion is to use these two techniques and rules or properties I have placed in our material. The first rule is the rule of successive alternate signs. This is the concern for the second term. So this second term, let's say minus 21, this is actually a combination of the subtraction symbol and a positive sign for 21. Again, the minus 21 here, or the minus in this symbol here, is actually minus positive 21 in that case. The rule the rule of successive alternate signs tells us that if we could have this, we can just simply interchange the two operations. And then by interchanging it, the operation will become plus and then negative 21. If we have negatives and plus, I usually use parentheses here. Why is this so? Why do I have this technique? And why do I do this? Again, it's easier for me to look at items just like in number one, where the operation separating integers is plus, because I could just simply jump into the techniques that I could do, just like when I said earlier, borrowed money and a money at hand or cash on hand. Diba? And then it's easier for us to do that because if I have here subtraction symbol, it will complicate things. So my goal here is to make sure that these two symbols here will become plus. Okay, so the first step here is this: retain the first term, -7, and by rule of successive alternate sign, just like this, I could interchange the positive number here and the subtraction symbol, and it will become plus -21, which is now more or less similar to item number 1. The terms are separated by addition. Secondly, for this expression here, I got use here the rules of successive alternate signs. However, I could use a property which is common for mathematics, wherein when two negative signs or subtraction symbols are written side by side, no other numbers are between them, we could just simply change the two negative signs and make it plus. That is actually the double negative property. So for this case, I have here my negative and negative. I will make it plus. You could actually see here a smiling person. I let me make it better as a guide. Okay, there's a smiling person here. The two negatives will become a positive answer. This would mean by double negative property, this is just simply plus, and what is left, there is not any more negative, plus 2. Again, the double negative property plus and then 2. So this is now the different form for item number 2. They are just still the same. We are not yet adding or subtracting integers, but we are just I am just trying to make it easier for us because it's easier for us to have plus than negatives. So again, the rule of successive alternate signs for the second term, and for the third term is the double negative property. And with that, I could just simply use the same concern I did in number 1. -7. I have utang, 7 pesos. And then, -21, another utang, another utang, 21 pesos. So again, for the first two terms, I have a borrowed money which is 7 pesos and another borrowed money of 21 pesos. I have a total of borrowed money which is 28 pesos. Okay, I have borrowed money 7 for the first time, and I borrowed again 21. So the total of 28 borrowed money, 28 pesos borrowed money. So it's still, since it's borrowed money, so I use here negative. And then you have here plus 2. Okay, so I'm just copying the third term. One of the possible mistakes that some of us will do or may do for this item is when we actually use or incorrectly use the concept of the MDAS. Okay. The MDAS sequence is actually allowing us to use the operations in this pattern. But it's not necessarily addition over subtraction first. I'm talking about this one. Some of us might say, I will add this 28 plus 2 and I will get 30 because it's addition first before subtraction. So my answer is -30. This is the misconception for MDAS because MDAS is not necessarily multiplication, division, addition, subtraction. It is more or less and better to be called multiplication, division, whichever comes first, and then addition, subtraction, whichever comes first. Addition does not necessarily to be used first than subtraction, but whichever comes first. Because if you do, again, you will make this mistake. So it's whichever comes first. So -28 first, you still have an utang of 28 pesos. And then assuming that you will pay 2 pesos, you still have utang. But your utang is not 30, but it is actually 26. That's why the answer is -26, not -30. Now, for this sequence of operations, we could do it better later. We can improve it into a better form of sequence, but later. Let's proceed to number 3. For number 3, we have here the expression -11 times -5. Why did I say times? Unlike in number 1, wherein there is a specific operation between two integers, and even in number 2, there is a specific operation between integers. Here, we notice that we have used here a parenthesis and writing the two terms, -11 and -5 rather, side by side. This would mean that the operation now is multiplication. We already go away with the use of x. Let's say 5 times 3. We do not use anymore the symbol for x for multiplication because if we're going to proceed to algebra soon, x here may mean something. So instead of writing 5 times x, which represents multiplication, we could write it as 5 and in parentheses x. So if it's negative here, simply place negative here. Do not subtract, just make sure of parentheses, and that would mean multiplication already. This is the reason why I made mention in number 3, this is multiplication. And we are going to use the rules of signs for multiplication. So we may have two different processes here. Let me show you the first one. The first process is when you're going to multiply or take this sign here for 11 and multiplying it as a whole term to the other. So multiplying two numbers with same sign, negative times negative, your answer will result into a positive number. A positive what? That is now the result for the numerical figure 11 times 5, positive 55. Again, multiplying numbers, two numbers specifically, with the same sign, it becomes positive and then 55. Or you don't need to write anymore the positive sign, you simply place 55 automatically means positive. Okay? Now, the other process here is when you will treat this later. Multiply first 11 and then negative 5. So we're just going to copy here the negative sign first and then proceed with 11 times negative 5. Now we are multiplying now. Again, we are not yet treating the negative here as the sign of 11. So let's take, for example, just like the rule of alternatives, alternative, successive rather, the rule of successive alternate signs, we have here plus. So we could take 11 as positive. So positive 11 times negative 5. We are multiplying two numbers with different signs. So the answer is a negative. Okay, we still have the negative here earlier. And then 11 times 5, negative 55. But here, you could see the process of the double negative property, which tells us that the two negative signs, just like in number 2, can be transformed into a plus or a positive sign. So positive 55, which then again result to, without the symbol of positive, just 55. So any of these two processes can be done. The first process is when taking this negative here as a sign of 11, or taking it later, but still they will yield to the same result. Before we proceed to number 4 and 5, let me give you an important reminder. The rule of sign for multiplication, when we talk about multiplying signs, multiplying numbers with the same signs, and the result is positive, and when the numbers have different signs, the result is negative. This is actually true to two numbers. Or if we're going to extend it, 4 or 6 or 8, even numbers, like even numbered terms. Because if we talk about three terms, let's say negative 1, and negative 1, do not jump into conclusion saying the answer is positive 1 because I am multiplying same signs. Again, the rule is specific for two numbers only. Because if we're going to do this step by step, let's multiply the first two terms. Negative times negative, multiplying same sign. So we have positive 1 times 1, 1, which is to be multiplied to the remaining negative 1. Now we are multiplying a positive number and a negative number. So our result is actually negative 1. Looking at the two situations, this is more correct because the rule again is mentioning only for two numbers. Now for three or more numbers, you could do it step by step. So it doesn't necessarily say that if the numbers or the terms have same signs, the result is automatically plus. It depends on how many terms are there. Similarly, if you have here negative 1 times positive 1 times negative 1, you're multiplying numbers with different signs. Do not say the result is negative 1. because that's the rule. Again, the rule is specific for two terms only. Because if we're going to do this step by step, negative 1 times positive 1, you have negative times positive, so you expect an answer which is positive. 1 times 1, you will have 1. So the result for the first two terms is negative 1, and you still have negative 1 here for the third term. But here, you're now multiplying numbers with the same signs. So negative times negative, you have positive 1, which is again positive 1. See, doesn't it does not it's not a guarantee that you're multiplying numbers with different signs you will get a negative answer, or you're multiplying numbers with the same sign you will get a negative you will get a positive answer. Sorry, negative answer and positive answer here, because the rule is just saying for two numbers. So if you have three or more, do it step by step. Let's proceed to number 4. Number 4 tells us to divide 32 divided by negative 24. Now, if we're going to do it like this, we are not going to make a horizontal process for division of integers. Instead, we are going to use the vertical process. By means of vertical process, instead of the division symbol here we call obolus, we are going to transform it into a division bar we call vinculum. This is now actually a similar form for a fraction. This is why when we talk about division of integers, we are going to come up with fractions. As mentioned in our module, only the division of integers doesn't have closure property. When you say closure property, if you're going to add integers or subtract integers or multiply integers, the result will still be an integer. But for fractions, some of the results or the quotient, when you're dividing integers, some of them will result to a fraction. So we are going to touch fractions right now. Again, the oblong symbol becomes vinculum, and the first term or the dividend becomes your numerator, while your second term or your divisor becomes your denominator. This is now the equivalent fraction form for the result of number 4. However, we can still improve this and simplify this further. Okay? By simplifying this in its lowest term, you will get 32 here as a product of 8 times 4 and negative 24 as a product of 8 times negative 8 times 3. Why do we do this? Because once we do that, we could use here the cancellation law and leaving the result to become 4 over negative 3. Okay. Before I present to you the other answers for number 4, let me give you and share to you again these three important rules that you need to follow. Number 1, when you talk about fractions and the result is a fraction, please do not give an answer in decimal notation. You might say the answer here is negative 1.33. But negative 1.33 is not negative 4 thirds. When you use your calculators here, negative 4 thirds is actually negative 1.3333. It doesn't end. That would mean the negative 1.33 is just an approximation. It's not an exact value. For us to make sure that our result is still the exact value, instead of giving answers in decimal notation, please express your answer as a form or a fraction. So if it's a fraction, rule number 1, stay as fraction. Number 2, do not just give the result in a form of a mixed fraction. Yes, negative 4 thirds is just equal, or 4 over negative 3 is equal to negative 1 and 1 third. They are really equal to one another. However, the concept of staying in improper fraction is very important before we could reach algebra, because in one of the process in the algebraic expressions, when we substitute them or evaluate expressions, it's easier for us to substitute fractions than improper fractions than mixed fractions. So starting right now, rule number 2, if the answer is an improper fraction, stay as improper fraction. And the third rule, which is of course the very important rule, we already did it here earlier, all fractions must be in its simplest or in lowest terms. Simplest form or in lowest terms. Again, these are the three rules starting right now. Please do consider this when you talk about division of integers and even fractions. Number one, if the answer is a fraction, stay as fraction. No need for numbers with decimal places. Number two, if your answer is an improper fraction, stay as improper fractions. No need to transform it into a mixed fraction. And number three, always consider answers in simplest form or in lowest terms. The answer here for number four could also be represented in two different ways. That is actually by rearranging or replacing or moving the negative symbol here. So instead of the negative symbol in the denominator, you can place it in the middle, negative 4 thirds, or place it in the numerator, negative 4 thirds. Nevertheless, all of these three are acceptable. Now for number five, this is a combination of all operations. You have here multiplication, you have your division and subtraction, which could actually again be changed into addition as we try to simplify it later. Let's have it here for number 5. Negative 7 minus 2 times 3, okay, minus 14 divided by, sorry, that's divided by negative 2. Here, we are going to use the sequence of operations we call Pemdas. But for this level of yours, grade 7, let us try to change it into a better form. We call it Pemdas. Pemdas. Okay. Pemdas means it's not yet here present, but I'm just presenting it to you right now. Before multiplication and division of terms, we need to consider terms under a parenthesis and then later on the exponentiation. The exponentiation is when you see here exponents. Not yet here, but I'm just presenting it to you here as PEMDAS. Or also, you could use here the term GEMDAS. GEMDAS meaning, instead, aside just from parentheses, we could also use brackets and braces for grouping symbols. More of this will be very useful and actually uh, possible for algebraic concerns later. So then again, let's talk about MDAS. Okay? MDAS muna tayo. When I talk about MDAS, again, it's not necessarily A before S, it's whichever comes first. So here, let's try to talk about M or D, whichever comes first. I'm going to do it step by step here. We have here a multiplication process, so let's do it first. When we start using this process here, do not change other terms. That would mean negative 7 still, minus, here you have minus 14, and then divided by negative 2. Now 2 times 3, okay, I'm taking here the sign of 2 as positive because it's a minus here symbol. So 2 times 3, you have 6. That's why you have here 6. Now we're done with multiplication. Let's proceed to division. Now, if we talk about division of numbers, okay, we have not touched this one. You have negative 7 minus 6. And you have here minus the result of 14 divided by 2. Using the vinculum symbol, you have 14 divided over negative 2. In lowest terms, you will have here 7 over negative 1, or just simply negative 7. This is what you're going to place here, negative 7 as the result of this operation. So we are done with multiplication and division. We can proceed now to a pair of addition or subtraction processes. This is again where students like you will get confused because of the negative signs. But I am suggesting to you earlier to transform it just like in number 2. You have negative here, 7 minus 21 minus negative 2. Instead of minus or negative symbols, transform it into plus or addition signs. And then by using rather the rule of successive alternate signs and double negative property. The first here, again, you have here positive 6. You can interchange the two. Let's use another color. You can interchange the two. So you have here negative 7 and you have plus negative 6. As for the next term, you have two double negative signs. Make it plus. You have double negative property here. So you will have here plus positive 7 right now. Again, the rule of successive alternate signs and then a double negative property here. And then here, you could come up with two different options. The first option is when you're going to combine this first term by the last term, because negative 7 plus 7 will become 0, and you will have to remain with the answer here, negative 6. That's the first possible solution, because we could just simply combine the first and the last term with ease. Or you could proceed with the step-by-step process here. Negative 7 plus negative 6, or let's say you have an utang of 7 pesos and then another utang or borrowed money which is 6 pesos. So you have a total borrowed money negative of 13. And then plus 7, copying the last sign, last term rather. And then again here, do not mistakenly use addition and say your answer is 20. 13 plus 7, 20, and I will use the sign here negative. No, again, whichever comes first. So you have negative 13. You have a borrowed money total to 13 pesos, and you will pay it with 7 pesos. You still have negative 6 or 6 pesos of borrowed money. Using the two different steps, here and here, we have the same answers. So these are the results for the first group of this pre-break session. Items 1, 2, 3, 4, 5, covering the 4 fundamental operations on integers. We'll try to solve item number at the next problem for the next video. So please watch out for that. Goodbye.